Haven't seen anything. Okay, forget anything you've seen. I almost spoiled my entry. Oh, yeah, go ahead.
Thank you. Some people missing. They left. Don't worry, it's not because of you. It's because of me.
It's okay.
Second talk is from Adam from Pure Storage, and
Yeah,
stage is yours.
I can handle it. No worries. I'm not that famous. Julie is very famous. So yeah. Thank you for coming. One thing to mention is if you're hearing the echo from the outside, we can just close the door. Yes, can we just close the door, please? Oh, awesome. Thank you.
That's a big one. Thank you very much.
All right. Before I start, and this is my first time trying this. So, have you watched any Marvel movies?
Yes.
Unfortunately. So I know they're lame. But have you watched the Avengers? Do you know Thanos? Right. So oh, by the way, I know I might spoil that for a lot of people. However, it's been like 4 years now, so like you just go watch it. You missed so much. So when Thanos, come on, Thanos. When Thanos was about to be defeated, he snapped his finger, and he wiped the half of the universe. Right. The Avengers were not ready for that. So what they've done on the next sequel, they went back in time to restore or recover a point in time. So they went back and bring the state back to full from half, right? And Thanos is always saying that I'm inevitable, right? So today I'm going to be talking about how you can prepare for the inevitable, how you can prepare for a Thanos event that can wipe half of your data, or maybe all of your data. My name is Adam Azuz, and I work as a cloud solution engineer here in Pure Storage. I've been designated as an AWS community builder last year, and this year I've been also awarded for a VMware vExpert, which is I think I didn't thought that I'm gonna get that. You can find me on LinkedIn. I post sometimes or on my blog, adamazuz.com. The agenda I'm going to be talking today about is a couple of things. One is, since we're talking about how we can prevent from the snap, and we're going to be talking about the resiliency of the cloud. And in order to understand the resiliency of the cloud, I think most of the people here, hopefully, they might know the resiliency on premises as well. So we're trying to compare that on the first section. Then I'm going to talking DR and HA architectures. Then I'm going to go with best practices. If you don't know what DR and HA stands for, this is good. I think I'm going to explain things piece by piece. So I'm going to start with what is resiliency. Resiliency actually can mean a lot of things. It can mean data loss, and it can mean business continuity. It can mean being able to restore your services. Usually when I talk about resiliency, I put it into two terms: availability plus recovery plans. The availability means that I need my system to be able to continuously operating without preventing the service from operating. Recovery plan is, on the other hand, is the ability to recover quickly from that event that's going to happen, right? So restoring the services, this is the recovery plan, and availability is to prevent loss of that service in the first place. So this is what the resiliency means. Sorry, I'm going to pause this because when I hit this, it takes 2 seconds to show. So this is going to be annoying for a bit. So please hold on a second. So there is a couple of questions to answer here. First is, what do we really mean by availability? When you think about a system that needs to be available all the time, the first thing that comes to my mind when I'm preparing this presentation is the plane, right? The plane has 2 engines, and the mean time before failure for the plane engine is too long, that if we lose one engine, while you're flying, the other engine will keep rolling and is going to make sure that you can land. The other question I think we have to think about is, why do we need a recovery plan? So the resiliency, as I said, is availability and recovery plan. Recovery plan, think about an event where, and I heard this story a couple of times actually, especially like back in the days when all Unix systems, when you're just gonna do this in a wrong directory, right? Exactly. Yes, the magic code. And if you've done it on the root file system, you're gonna start like seeing things start disappearing piece by piece. So to put this together, the last question we need to answer actually is, what are we planning for? So we know that we need to have some resiliency in our systems. We need to make them available. We have to have recovery plan as well. So we're planning. What we do actually, we planning for a couple of events, and mostly are the disaster, Thanos events, like the snap. I have 4 examples here, and most of these examples are real. A lot of problems happen for a lot of enterprises and companies. First one is natural disasters. I mean, we live in a world, especially now with climate changes, there's the state of your data centers, of your data is not protected by any mean. Nature can flip the table on you. The second one is local outages. A fire is going to go on the building, or sometimes it means technical failures. All the equipments, the services, appliances you have on the data center can fail. Disks, CPUs, memories, all those, all the components within a data center have an annual failure rate or a mean time before failure that you have actually to design and protect them for. And the last one is human actions. We heard about a lot of those things. Julia was talking about a couple of ransomware events can happen. And sometimes actually it might not be a cyber attack. It might be an employee just went wrong. It just got laid off. Hopefully it's going to happen to none of us. And you're just going to corrupt or encrypt all the data that you can access to your enterprise or your company. So what if the recovery is not achieved? So we talked about resiliency. Resiliency is availability and recovery plan. And then there's a disaster. If a disaster hits you and you cannot achieve the recovery, whatever the recovery looks like, which is we're going to be putting all together by this session, is you're going to lose your repetition. And then you might start losing your employee productivity. And the last one is kind of combining both. You're going to be losing revenue. You're going to be losing dollars at the end of the story, right? So let's take a step back now. We mentioned the resiliency, as I mentioned, as I talked about. I haven't specified where we're taking care of this resiliency of our systems. I came from an on-premises world where resiliency means a lot of different things there. Resiliency means that I'm going to have a server that has 2 fans, 2 power supplies. It has I can scale it out, can scale it up. I have storage systems or storage arrays that are reliable. They have 2 controllers, RAID levels, erasure code, stuff like that, right? In the cloud, it's different. And the cloud built their business on, and when I say cloud now here, I'm saying AWS. I don't want to piss off the AWS guys we have here. And the thing is, resiliency in the cloud in AWS does not mean that it's someone's responsibility. It's I think as a shared responsibility. And Julia actually she shared this with you in her session, and I just want to touch base on it again. So if you think about AWS, they build all their global infrastructure on top of entities they call them regions. Each region will have a bunch or a couple of availability zones. Each availability zone has 2 or 1 or more data centers. And the data centers actually is, again, they have a separate power supply or power units, fans, cooling, and all of that stuff. So this is kind of the global infrastructure. And then they build hardware and services on top of that inside those data centers. They have compute, they have storage, they have networking. So they are responsible of the cloud, right? And then comes the customer. Customers start using those services, those hardwares by the on-demand or pay-as-you-go services that all of us actually been trying and testing, right? Or building your business on top. So the customer comes in, and the responsibility to build architecture, workloads, and networking on top of this resilient hardware and services, but then they have to take care of that architecture. You don't have to go there and create things in one availability zone and say like, oh, my data is in 2 data centers. This is what the AWS are talking about. No, you have to make sure that you're building your architecture on in a resilient manner, and also you have to do data backups. And I think we had a lot of best practices that Julie already mentioned here. So since we talked about architecting stuff, I thought about let's do this in a couple of scenarios. And these scenarios might click to a lot of people. This is architecture you've done within your organization, or you're thinking about doing. So let's try to architect for high availability first. And we're thinking about high availability. There is always, you do not do things on one availability zone. And what I'm presenting here actually is the traditional 3-layer application where like you have a front end, the application layer, or the logical, and then like you have a database where you're saving the state of your application, right? So usually when you're building for availability, what I mean here is that I am having an auto-scaling group or any kind of replicating my infrastructure in 2 or more availability zones. By that mean, if one AZ is going to go down, I still can access my application. I still can have a functional. If I am using RDS-DB primary, it's going to just the standby or the replica is going to go to be primary here. So then this means that I'm spending money here actually, right? Because money is, again, it's what we're designing for. But think about the preventions or the service level agreement that you've promised your customer to do, right? I don't want to, when this goes down, I'm not able to access my application. Let me rebuild that in a day or 2, right? Does not work well. This is what I told you about, sorry. So architecting for high availability, it's not a disaster recovery architecting. There is a huge difference between both. And you know, at the end, high availability plus disaster recovery plans means resiliency. So we have to have both. And in order to have both, I think disaster recovery is touching base the resilient system in different ways. And in order to understand that, I thought about like explaining how businesses are building service level of agreement. They're building that on top of 2 terminologies. I mean, we had I think for decades now, the recovery point objectives and the recovery time objectives. So I don't want to waste a lot of time here, but recovery point objectives means that this is the amount of data loss I can tolerate. So means that, in other words, if my snapshot frequencies is 5 minutes, this is your RPO. That means that what happens after that 5 minutes until the next 5 minutes, this is the data loss, right? So this is RPO. RTO is that the downtime that you can handle. So my application went down, how long I can wait until the application is going to come up and running again. So let's put all the things together. This is kind of the well architecture pillars, I think reliability pillars diagram that AWS are putting together for us to design our systems to be resilient systems. So usually when I start talking about this, it goes from, is my architecture go well with having a backup and restore strategy? This means that I can wait hours until if something goes bad. So this is always going to be the case. I'm architecting for things might go bad, right? So if things goes bad here, on a backup and restore. That means that I can wait for hours until I can bring the state of my application, and it's going to be the cheapest thing. Lite means that I think I'm going to be covering this in the next slide or two, but stick with me. The more you go, the more you are achieving near real-time business continuity. So if one side goes down, the other side is going to be up and running in a real time. I'm not losing data. My infrastructure is actually duplicated here, but that means that I'm spending the most. It's the most costly here in this scenario. So let's deep dive into architecting for disaster recovery. There's two scenarios when you think about this here. One is multi-AZ-DR, means that how I can think about my one region infrastructure and how I can protect against anything that can happen to one availability zone, right? So if let's go back to the same application or the 3 layers application that we've presented the last time. One is we have to protect against two kind of services. AWS, they have zonal services like Elastic Block Store or the EC2 instance. Each EC2 instance, when you create it, you're creating it within one availability zone. That means that it's running on top of one of the hosts, one of the physical servers that is located in one of the data centers. And when you're attaching the storage to that EC2 instance, that's exactly, actually, it's located within the same fault domain, right? So protecting those zonal services, I can leverage snapshotting, right? I can take snapshots from those volumes and then protecting them in the same region, or I can send them cross regions or cross accounts if you're worried about someone's going to hack into your account. So you still have this second layer of defense. Protecting protect against any problems can happen to regional services. Regional service like S3 buckets, the object storage that you might be leveraging for your application. So one of the things that you can use here is versioning, which is like just go to your bucket, click enable versioning, and then when something bad happens, and by something bad happens, it might be a cyber attack or someone just by accident delete a couple of objects. So I can just roll back to the previous version. DynamoDB is as well a regional service as well, and you can do point-in-time backups for that as well. Now we covered the multi-AZ DR. Now let's go into kind of more advanced regional DR architecting. I'm going to mention 4 things, which are basically the ones you've seen from DR strategy. Backup and restore. First, it's an active passive kind of architect where you can one region where I'm going to have my instance. I can have my maybe RDS databases, and the other region is empty. So I can use AWS backup services to create automatically create snapshots from that EC2 instance or from the RDS or from your EFS, whatever. AWS backup actually really support a lot of services, and you just select the region to be the second region. And when things goes bad, you need to bring all the state up. So backup and restore works as I have my infrastructure in one region, both my infrastructure and data, and then in the second region, I don't have any. When something gonna happen, I'm gonna build both the infrastructure and again, restore the data, right? Because when I mean restoring the data, the backup here, actually, if I have EBS storage here, backed up to my second region, that means it's in an S3 bucket. Restoring it from the S3 bucket is gonna take its sweet time. Ask me about that. The second one is Lite. Lite actually it's faster. It can go to up to RBO of minutes or less than an hour. And usually when people using this kind of architecture, they're putting some kind of a load balancer or some entity that can handle the requests, like the 53 routes. It can put in top of the regions, and then requests come from the 53 to the active region. The difference between backup and restore and Lite is I have the data is being replicated. So if I'm using the Aurora primary, if I'm using Aurora databases, I'm going to keep this as a primary, and then I'm using the async cross-region replication to have an Aurora replica on the other region. So the difference here is that I have data in both, but I don't have an infrastructure. If I'm using auto-scaling group, which is, I think this is where you're going to be using it, you have to keep it with no instance running. So you have your launch configuration there, launch template, we're going to call it. And then when things can happen, and I did snap, so if you're still with me, Thanos, if things happen here, I'm going to switch to this. It's going to be active. Auto-scaling group is going to go to desired state 5, 10, whatever his application is running. And this is it. The other thing, and I think it's not that famous, I like it because it works a lot for, especially for those who's building their architecture on top of EC2 instance, is using Elastic Disaster Recovery, DRS. DRS is a new, kind of new service. It was called Cloud Injure Disaster Recovery, right? Yeah. And what you can use with DRS, it's kind of a DR as a service service, is you select a couple of EC2 instances, you protect them to a specific region, and then when you can use drill testing, that means that data is going to be automatically replicated to the secondary region or the secondary availability zone. So it's a block level data replication, means that there's going to be an agent on the EC2 instance that is replicating the data to the other region. Once you want to drill test or once you want to fail over the other region, you're just going to hit the button, all your infrastructure is going to go up. And DRS is kind of a pilot light. You're with me, I'm not losing you. There's two more. The other one is warm standby. Warm standby is kind of similar. It's one more thing is that you have a bunch of infrastructure running. Either that is to instance, Lambda functions, whatever. You have some infrastructure state here that if things goes bad, it's a warm standby, right? Things are warm here. There's still just need to scale them up, and then it's part of minutes. You can get your secondary region up and running. Last one is the multi-site. Multi-site works as same exact infrastructure. Data exists in both, and by having data exist in both, this is a really challenge. Not all the services can maintain that synced replication. That means that wherever I'm writing to region A, I can read it from region B. And the only, I think, database can work for that from native database services in AWS is the DynamoDB, because with DynamoDB, you can have a global table, which has an auto replica activated by default. So whatever you're writing to that table, it's synced in a near time between both regions. You have to pay for that. It's not that cheap, but what you're gonna have with this, if this goes down, snap, you still have access in a near time here. You don't lose anything. You don't lose your access. The users won't feel anything. But yeah, again, costly as the way I'm talking about it now. So I'm not a literature guy. My wife is, and Franz Kafka, I think he resonates with this problem as much as I think it's better to have and not need than to need and not to have. And this is exactly for recovery plans, right? You have to have them. Okay, so we talked about RBO as much, I think. So RBO again. RBO. Thank you, Sandra. So recovery point objectives is the ability, is how much I can lose data, how much I can tolerate. The frequency of my snapshots. This is kind of a nice way to keep it stick in your mind. The thing is, lowering the recovery time objectives is as hard as it gets. RBO is a bit easier to achieve. RTO is how can I lower that? I can have no downtime. This is the optimal way, but how can reduce that downtime? So there's two things here I like always to mention. One is that initiate the failover as quickly as possible. So think about here is that like the pilot light or the warm standby DR strategy. If I know that there is a disaster happen, there's a snap, I can initiate the failover manually because I know that it happened. I'm not able to access the website or whatever application, or it can happen automatically, right? But the thing is, failing over automatically, it's doable. You can build. I'm going to talk about that in a few. Actually, I don't want to spoil myself. The second thing is, so this one can happen with human interaction or an automatic, right? Early disaster detection is the hard one. You don't want to sit there having a lot of dashboards under the company trying to observe, oh, there's an anomaly there. Oh, I think we have a disaster. I think we have a cyber attack. It won't happen. It won't be as fast response as you think. But having some automated kind of way of observation, some observation tools, actually some CloudWatch or logs, metrics, traces, all of that can help. And this is exactly what I'm going to be talking about in this slide. How do you know when a disaster event occurs? There's a couple of patterns, right? I've used them a couple of times, and I think the AWS, they've put together a lot of nice services that you can build your toolings on top of that. First one is to use CloudWatch metrics or logs or alarms if there's built-in, or you can have custom ones. So you can, since there's an anomaly within your system, push that. Whenever you're going to have something, you're going to push that to the event bridge. This is one, I mean, like from your own system, your own services. The other one, is to have the AWS personal health dashboard, which is kind of sensing if things are going well from the AWS themselves. So as I told you, there's the responsibilities shared, right? So if something's going bad with AWS global infrastructure, with their hardware services, you should have it here, and then it's going to be pushed to the event bridge. Event bridge is going to take it. Then okay, now there's a problem. How am I gonna keep you warned? So there's the SNS. If you can build it on top of SQS, or the SNS is gonna send you a notification to your email, and then it's gonna hit the start the failover action, which is, as I told you, it can be initially it can be triggered by some automations. It can be Lambda functions, and then can be orchestrated by step functions. And then after that, it's up to you. As I told you, there's a couple of ways to recover your data. DRS is one of these things. You can have the automated failover to another region if you're using EC2 instance, or you can restore from a backup, or you can build your infrastructure using some CloudFormation templates, right? And this is actually the nice way of always having a backup of your infrastructure, not your data is, I mean, you have to have a backup of your data, but like having a backup of the state of your infrastructure. I think now it's like, I mean, I've been talking about AWS, right? So now a little bit of the orange. This is the product I care about the most because I work on that product. Pure Cloud Block Store is a software-defined storage that we built on top of the cloud services. So when you think about a software-defined storage in the cloud, the first thing you think like, why do you need to have a software-defined on top of software services, right? But when I look at it from a lot of point of views, especially like from a developer point of view, AWS have been building and innovating in a lot of services, and they want people to build on top. There is a lot of cool toolings, a lot of cool infrastructure can be built just using some services like Lambda functions, and serverless architecture is one of the greatest things I think you can build on top of that, right? So we've done the same thing. What we've done, woohoo, pizza. So what we've done is we looked at the most use cases that the cloud people are using, right? And then we looked at the services provided by the cloud themselves, storage stuff. We looked at the instance store, the ephemeral storage that attached to the EC2 instance upon creation. That EC2 instance actually have an ephemeral NVMe, very fast, low latency. But once the EC2 is gone, it's gone, evaporated. right? So great performance, low resiliency, right? Then we looked at S3 buckets. S3 is an object storage, and it's very durable. Can go up to 11 nines of durability. And sorry, I'm not going to be able to explain the nines and stuff like that maybe next time. But this is the S3 bucket. However, it's an object storage. Not all the applications are leveraging object storage, right? And in the same time, it's not that performer. Like you need to do a lot of things to make it perform. And then the last one is the EBS, the famous elastic block storage, which is just providing block devices to your machine, and it can overstay the life cycle of your EC2 instance. If you delete the EC2 instance, the EBS is going to be still there unless you select to delete it. The problem with EBS, I'm not saying the problem. There's good benefits, right? The thing is, EBS, they have different types. There's types where you have to, I'm going to put that. I don't want to look bad in front of EBS guys. There's a couple of types, right? One is the provision IOPS. Provision IOPS is the highest performance. There's IO1, there's IO2, there's IO1 block express. All of this is very performant. And the problem with that is when I'm creating a one block storage, and I'm talking about this from an on-prem storage arrays kind of experience. When I'm creating one volume, attaching it to one EC2 instance, and then I'm writing data to that EC2 instance, to that block, right? And then I create another EC2 instance. I have another one there, right? Both are writing the same data. I'm having two exactly the same data on two EBS storages. That means that I'm creating silos here, right? There's no storage awareness. There's no data reduction. There's no storage efficiencies. And the second problem is when I'm creating a volume, I'm choosing to thick provision the capacity. Like if I select 1 terabyte, I don't know if I'm going to use it or not, right? And then the second thing is thick provisioning the performance. I think you haven't heard about that maybe until now. Thick provisioning the performance means that I have to create my volume to have certain IOPS limits and certain throughput as well, right? And usually, actually, sometimes it's linearly. If I select that capacity, I have to get this IOPS. If I want more capacity, if I want more IOPS, I have to select more capacity, and etc., etc. So, how we thought about the problem and how we fixing it in a cloud storage native way. Before I'm going to show you the architecture of that, let me just show you a couple of use cases. I thought I'm going to do some animations, so it's going to be less crowded. So sorry for that, I forgot. So let me walk you through that. Cloud Block is a zonal service, means that it's created on top of zonal services like EBS, EC2 instance, right? And then it can expose storage, a block device through the network to applications, databases. Most of the use cases actually that we are having today is our SQL, Oracle, Epic, those kind of enterprise level databases that are requiring a couple of things. One, storage efficiencies. Storage efficiencies mean that if I created a volume, it can be thin provision. It can have some data reductions because I'm aggregating the storage in one pool. If I'm going to go back to my examples and have two virtual machines writing the same data, in the back end of my pure Cloud Block Store platform, I'm seeing 1 byte. I'm not seeing 2. So I'm reducing the data using the duplication compression and also a lot of other technologies because we haven't invented that software just for Cloud Block Store. We've been using that software running on this environment in our on-premises arrays as well. So this technology has been evolving by the years. And one more thing is that snapshotting, or if we're talking database admin terminologies, copy data management. If I create a snapshot, I want to create it instantaneously. I want to clone it in the same time. So this is the platform is going to help you with that. If I have 3 terabyte or 10 terabyte of data, I want to clone them. Now I want to present them to a read replica, a database, or I want to clone them for dev testing. Right? Things can happen instantaneously because again, it's one pool of storage. The software on top of that is taking care of it, and it's always mapping to the bytes that have been written. So if I want to create a different copy, those points to the blocks, it's just going to be like pointed again. So it's just pointers and a key value database. So I don't want to bore you with a lot of use cases, but I want to show you what I mean when I say that we built it from the cloud native storage and we built it for resiliency and reliability. It is a zonal services. However, we've taken those reliability and resiliency numbers to the maximum because we're leveraging not just the EBS, not just the EC2 instance with the thermal instance store, also with the S3 buckets. So we're all together, and this is the way how we do that. Okay, first is we having two EC2 instances. We call them the controllers. Those controllers are just the front end. That means that we're exposing those network cards, and then you can present your storage from that. Those controllers are stateless. We're not saving the state of whatever you're having here. We don't have the customer data here. Then this data is actually goes all the way to something we call virtual drives. Those virtual drives are, again, EC2 instance with instance store. So you can see that there's an instance store, the orange one, and and each one of these EC2 instances are provisioned in a spread placement group. If you don't know, spread placement group is actually, think about it, rack units. Like, do you know the racks in the data center? Each rack, or maybe a fault domain within a region or within an availability zone, is called a placement group. So all of those 7 disks or 7 virtual drives are spread in the placement group, and they put on top of an auto scaling group. So if things goes down, which things can go down, because the annual failure rate for those EC2 instances can mostly be seen 3 or 4 over the year. This is the minimum. So auto scaling group, that means that it's self-healing. If things goes down, it's going to bring another one, spread the data. Other things. So we have an EBS IO2. The reason for that, and we're leveraging actually every single stuff. So when you see this, you think like, oh my God, like we're spending too much. But in the meantime, if you're having 100 VMs and you're putting all the data within this, you would see the data reduction. So the EBS is actually for the low latency. So when I write IO, and hopefully people here knows about IO, write, read. So when I'm writing to the back end, the write goes all the way to here. Then it's going to go back acknowledgement. Hey, I have the write. It's low latency, so it's going to be the quickest. This is not as the Athena snap, sorry. This is quick snap. Then the instance store is where we flush data. So we acknowledge it in the low latency EBS, then we flush it down to the instance of store. The reason why we're having this here is because instance store kind of cheaper than having an EBS. So if you see those EBSs, there are 6 GB each. So we don't store data in the EBS. We store that here in the instance store, and each EC2 instance would have 2.5, I think, the average of terabyte. And then after that, once it's written to the instance store, then we flush it down to an S3 bucket.
Sorry, can't an instance die?
Absolutely, yes.
So you're flushing from EBS, which has some kind of availability, to instance stores, which does not.
Absolutely. The thing is, we're using this for low latency. Then we're flushing it here because we know that it's going to be a thermal. Once it's here, in the same time, we're flushing it to the S3 bucket. In the same time. So if all of this goes down, we can bring all the data back because it's all in the S3 bucket, right? DynamoDB here is to store the metadata and the configuration. So we don't store data here. We're storing that, this array is just have some 7 disks. This is the ID, this is ID, this is ID. Just making sure that there is a state here outside. So this is how we built it. And this is how I build stuff on top of it. So think when I was showing you all the disaster recovery things, we have customers using the Cloud Block Store, and they want to integrate it natively with the DR strategies, with the well-architected pillars that the AWS are providing. So this is one of the solutions that I built for one of the customers, is that how we can leverage the Cloud Block Store, because Cloud Block Store, as I told you, it has a lot of built-in technologies like replication. So replication is natively can be is part of the software. So you can access it, you can select volumes, can you replicate them to a different region, to a different Cloud Block Store array that sits on that region, right? So if you think about it this way, if I want to do an active passive DR as a service, and I want to use Elastic Disaster Recovery, what I can do is I can put together some detection system that would know, hey, I think I think we have to mention this. When I'm thinking about detection systems, usually don't go with, I want to have livability or Bing tests. Bing tests are not, this is the worst kind of way of detecting a problem within an application. Always go for some services are down. Oh, okay, now this is an indication. There's other stuff like you can design patterns, you can go for detection. I'm not gonna go through all of those. Then like this is gonna send an SMS notification, then the SMS notification is gonna trigger some lambdas within a step function orchestration, which is just gonna go to make sure that, hey, I have this EC2 instance running on that region. Can you now just start running them up and running on the secondary region, right? And once it's that up and running, one lambda function is gonna talk with the Elastic Disaster Recovery to initiate an automatic failover, and then the next one is gonna send some API calls to the Cloud Block. So like, hey, this is a DR event, promote the volumes on the secondary region, right? And then just gonna attach those volumes to the EC2 instance. This is one solution that we've provided to one of the customers who's gonna lower their RTO to minutes. The second one is an active multi-site. And if you remember that one of the services that can do active is DynamoDB. But not all the customers are leveraging DynamoDB because sometimes it might be some problem with refactoring their applications. So they have to refactor to build things with DynamoDB. So there's some customers who are like, oh, I have this Oracle databases that you can use some stretch cluster. There's some Oracle suites called Rack, and there's some SQL failover groups that can stretch one volume. So it's not logically, it's not stretched. It's just having two volumes within two systems that those two systems actually are syncing. How? Now the cluster is this. So this is a kind of full cluster. When I'm writing here, the acknowledgement is not coming from here as usual as any storage system. Acknowledgement goes all the way until I have my byte written to the other side, then okay, acknowledge. So now I'm making sure that the data is consistent. There's no corruptions, and if this goes down, the RTO RPO is 0. And that's expensive. Absolutely. Absolutely. Not everyone can leverage this. And for your knowledge, actually, yeah, I was waiting for actually your questions. Don't worry. One of the things that when we look for active scenarios, not anybody can use that. Always enterprises that they don't allow any downtime for their services. Your SLA means that you don't have any downtime, so that's expensive. But to provide kind of an SLA, that means that you're earning a lot of money. That's the trade-off here. All right, I think some takeaways. Sorry, I think I hold you for too long. I think I was talking too much. Takeaways. So avoid those anti-patterns. And by talking anti-patterns means that avoid them by any chance. Replicate problems from on-premises. If you're getting from on-premises to the cloud, don't expect it to work the same way. As I told you, resiliency means differently in the cloud. Then putting everything in one AZ and just mimicking kind of a data center architecture. Manual monitoring, alerts, and metrics. Always try to use what the cloud is offering. CloudWatch is for free, unless you start like using the detailed one. Manual data backup and retention. Don't just go every Tuesday to back up my system. It should have some frequently backed up and some retention actually for the backups. And as a wise person said, come on, don't sacrifice long-term values for short-term results. Yes, someone wise. Yeah. The second takeaways I'm going to be talking about is, please. Yeah, define your HA and DR plan. Always think about my SLA, what I'm providing. What kind of thresholds I need to think if I don't have unresponsive IO? When should the application time out, right? Are you able to fail over and fail back? This is all the things that you have to think when you're designing for the DR and HA. And if yes, you can fail over and fail back, please drill test. And again, as another wise man and a wise person said, is do drill tests and test the tests and do that more often. Yeah, I just came up with this one very quickly earlier. Yeah, so that's pretty much it. So if you have any questions. I don't know.